Today I wanted to cover a few tips that I've learned using my logic analyzer to develop a circuit over the last few days. I'm using the LA2016 model. It's a little bit faster than the base unit. I got it from Amazon. The first thing that you want to set is the number of samples that you're going to take. This will translate into how much time you're able to look at. You want to also set the sampling rate. You want to be 5 times the smallest signal that you're looking for, and so that you make sure that you pick it up. The faster your sample rate, the fewer the number of channels that you'll be able to actually use on the device. It will support up to 16 channels. I'm only currently using 8, so I'm able to stick at 100 megahertz for that. When you're ready to go ahead and look for your sample, you're going to hit the trigger button here. But before you do that, you want to select one of these channels here and then select whether it's a rising edge, falling edge, or in the middle if it's just at a particular level for that. So I'm going to select a falling edge on this right signal from the H89 that I'm using, and that will start my data acquisition. Notice that even though 0 is the start time where that first event occurred, it does give you time before that, so you can look and see what happened before your signaling event started. So I'm going to go ahead and trigger this to wait. It'll wait for the trigger. I go ahead and run the program on my Heathkit H89, and I get all the data coming back. The first signal I'm looking at here is just really for reference. It's the clock signal off the H89. Looking at this, if you put the cursor over any one of the periodic signal here, it will tell you that the width of that is 80 nanoseconds and the frequency is 8 megahertz, which is what my H89 is running at. So the first event that I was looking for in the trigger was here, and I want to go find that, so I'm going to hit the T button here. That'll bring up the first event. If you use the wheel on the mouse, you can shrink the view or expand it simply by rolling that mouse. You can also do it with the buttons up here, but the mouse wheel is way faster for that. If you want to scroll the window from left to right, left click on it. You can scroll the window easily using the mouse that way. I'm going to go ahead and expand this out. And this is the read signal here. I want to find the next read signal. So if you put the cursor close to the edge of the window, you'll see that highlight appear. Click on that. That'll take you to the next event. Now I'm looking at the serial data line up here, and I want to see how that relates to the clock signal generated by the ESP32. So I'm going to use the timing marker pins. And if you click plus, it'll give you a multitude of different options here. You click on A1 and you can go ahead and put that right where you want it. Grab A2, and then I'm going to put that on the rising edge here of the clock signal, which is what triggers the integrated circuit I'm looking at. And you can see that when that rising edge occurs, the serial data is high, so that would be a 1. If I go to the next rising edge, the serial data is low, so you'll see that that would be a 0 for that case. So it's very easy to use these timing marks to be able to look across multiple tracks for that. All right, so we talked about the period measurements that happen automatically when you're on a repeating waveform. In this case, the period down here is 470 nanoseconds, and the pulses are slightly offset a little bit. The 250 nanoseconds for the first and 220 for the second. So since this is software driven, there is a little bit of a timing difference between the two that you can see. And I believe that covers everything that I've learned so far. Have a great day.